Hi everybody, welcome back. I'm going to call this video a miscellaneous video for week 1. I've been getting emails from not all of you but some of you asking. There's a couple of questions on homework 1 that somehow got cross-contaminated with week 2 material, and I would like to take this time to sincerely apologize to everyone that may have run into this issue. Okay, my initial thought was I was going to address it during our Zoom conferencing on Saturday, but I figured it will be unfair. What if some people can't make it? Even though I record the session, they would still have to go through and look at that video, and if they couldn't look at it before, it might lead to some issues. So I figured, you know what, I'll take my time to make another video just to fix that issue. Okay, now there's only 2 questions and I know exactly what those are. I believe it's one of the questions with the ions. We did address ions in week 2 videos. We went over them in depth, but I'm just going to take the time to just go over it so that we don't have that problem. So let me get my brush. All right, so some reason it's very difficult to get this brush too. All right, so on a lighter note, there is one thing I do want to point out that was not part of the confusion is atomic number is also customarily referred to as a Z. So on homework, if you see Z equals 19, that means this is the atomic number of that element, whatever element you're looking at. Okay, so therefore it's got 19 protons and 19 electrons. Nothing has changed. It's just some textbook or resources or some other chemistry people would refer to atomic number as a Z. Right, now that's not part of the confusion. I guess everyone seems to be doing okay with it. Now the reason I don't want to do it extreme detail is because it might conflict with your thought when you watch week 2 videos. All right, so let's look at an element without its ionic charge and then address it. I think that will be the easier way to tackle this problem. All right, so let's say we do calcium. All right, let's find our periodic table and get the atomic number for calcium. So that is 20, right? So calcium's atomic number is 20. That means it's got 20 protons and 20 electrons, right? And it's in group 2A. I think everybody is comfortable with that part up until now. All right, so that means calcium is a metal and it can only lose 2 electrons, right? So the maximum it can make would be Ca2+, right? And at this point, I don't think I've even talked about valence electrons or valence orbitals. Okay, so we're going to have to do this slightly different, okay, because that's all covered part of. To understand ions, you really have to understand valence electrons and valence orbitals, and that's all really explained in depth in week 2 videos. Okay, so without doing that, however, you have learned how to write the configuration, electronic configuration for calcium, right? So I'm going to write the configuration, and I believe it's in the 4th row, so it's no problem. So 1s, 2s, 2p, 3s, 3p, and I believe it is 4s. Okay, this is what you should have had. Okay, now if you start filling in electrons, I've explained that s orbital can hold 2, p can hold 6, and d can hold 10, f can hold 14. So going with that, you should have had this. Okay, now if you watch week 2 videos, I've explained how to write these configuration for an ion. Okay, week 1 I explained you how to write configuration for an element. In week 2 I explained how to write configurations for an ion. All you have to do is get rid of some orbitals if it's positive. Okay, all right, now 2+ means, okay, it's lost 2 electrons. Okay, all right, that means 2+. It's not F, it's 2+, right? That means you cannot just, if because this is where the nucleus is, okay, this is where the neutrons and protons are, and these are your shells, okay, these are your shells, and you can only remove an electron furthest from the nucleus, okay. What is the furthest from the nucleus? Let me get a different color. It's right here, 4s, okay, that's the furthest, right? And how many electrons does it have? It's got 2 electrons. And how many do we have to remove to get from Ca20 to 2 plus? It's calcium 2 plus is 2 electrons, right? So all we have to do is, just when you write for calcium 2 plus, we cannot have that orbital because it's lost its electron. You cannot write 4 as 0, okay? If it's lost an electron completely, that the orbital becomes empty, that means it has to be written without it, okay? You only write the orbital if it has at least 1 electron. If it doesn't have any electron, you cannot write it as 4 as 0. You can only write it as this right here, right? What does it mean? When you lose plus means, I've said you only lose electrons, right? Plus means you lose electrons, negative means you gain electrons. What that really means is the number of neutrons and protons never change, just because an element becomes an anion or cation, okay. We've looked at a cation, okay, just because an element, okay, becomes a cation or anion, okay. We've looked at a cation which is positively charged. We went from a calcium to a calcium ion, so this is a cation right here because it's got positive charge, right? Let's look at an example. Now, how many electrons does it have? I mean, now right now calcium 2 plus, okay, we started with 20, now we have only 18 electrons, but it's still has 20 protons, okay. Okay, now to find the number of neutrons, I've also explained that in my video very clearly, okay. Now calcium is 40.08. I believe I even did the calcium as an example, okay. Calcium is 40.08, right? Now, as I said, if this number is 5 or above, then you round it to 41. Since this number is 0, we round it off to a 40. That means 40 minus 20, right? Right? 40 minus 20, our atomic number is, well, you don't do the 18 because remember the formula is to find number of neutron is atomic number, atomic mass minus atomic number, okay. This is nothing to do with whether you made calcium 2 plus or calcium 4 plus or some other minus ions, okay. It really doesn't matter. You still have to go to the original atomic number, and that was 20, so we have 20 neutrons. Does that make sense? Okay, if you don't understand it, for now just tackle with this one because I've given all the explanation that you need. I think even there's one question which asks you to fill a table of protons, electrons and neutrons. You would know exactly. If I can go back and get a different color and put this inside a box, okay. This is the statement you really need and the understanding from how I worked this out to fill this entire table. All right, now let's look at one more where we are adding an ion. Again, all this has been explained in week 2 videos. All right, so say nitrogen 3 minus. Okay, and I even explained why nitrogen can gain 3 minus, because nitrogen is in group 5A and there's a magic number of group which is 8A, the last group, okay, that's octet, okay, it's called magic number or an octet. All elements that are non-metals, okay, non-metals, okay, would like to go to 8 from whatever they are. This is only for non-metals. I repeat, for non-metals. So that means it has 5, it needs 3 more, right, to get to 8. So nitrogen would always take 3 electrons. As I've said, non-metals like to take electrons, so they make anions, and that's why we have N3 minus. Okay, oops. Okay, that's a huge brush, 32 size. All right, so all right, there we go. So now how do we do this? First, you got to go get the atomic number of nitrogen, which I believe is 7, right? So write 7. Okay, so first write the electronic configuration for an elemental nitrogen in its ground state. So that would be 1s2, 2s2, 2p3, and that was not hard at all. In fact, I believe I did the same example when I taught you this in week 2 videos. In fact, I did remember doing nitrogen. Okay, so again, 3 minus is not same as just a nitrogen. Okay, this is the atomic number. So 7 means it's got 7 protons and 7 electrons, right? So we do have 7 electrons here total. But when you have nitrogen 3 minus, okay, we are going to add 3 electrons. Okay, and the rule is the same. Okay, you don't, so this is where the nucleus is. This is the first shell, this is the second shell, and the third shell. You add electron, okay, you add electron to the furthest shell. Okay, okay, furthest shell. All right, what does that mean? Well, the furthest shell is, I'm going to get my blue color and mark where that furthest shell is. It's right here. Okay, you cannot just go and add 3 electrons into, oh, I'm going to evenly spread it out, or I'm going to pick 1s2, or I'm going to pick 2s2 or 2p3. There is no choice. Okay, there is only one default orbital to which those 3 electrons can go. And okay, let me box this and add another statement in red and box that as well, because if you're going to do that homework problem, you would probably need both these statements. All right, so p orbital, as I've said, I've made that clear in week 1, p orbital can hold 6 electrons, right? Total 6 electrons max, right? And how many do we have right now in the p? Well, 3. See, it all works out, right? It seems like the destination's pre-planned. It seems like everything, the picture's done well, right? So P's got 3 and it needs 3 more. See, it is so perfect, right? And that's why I love chemistry. It's so perfect. I mean, it is perfect. 1s2, 2s2, well, just change the 3 to a 6 because now you've added 3. Now can you see the difference between nitrogen and nitrogen 3 minus? Do you see it? I added it to that. And now again, just because an element is a cation or an anion does not change the number of neutrons, right? So to find the number of neutrons and protons, well, it's got 7 protons, so N3 minus would still have, it has, well, we started with how many valence, I mean, it has a total of, we started with 7, we've added 3, so it has 10 electrons total, right? And it has 7 protons, that does not change. To find the number of neutrons, we got to go back to the periodic table. Nitrogen is 14.01, its atomic mass, right? 14.01 atomic mass, right? Right? What does that mean? Well, this number is still less than 5, so we just round it off to a 14. So number of neutrons would be 14 minus 7, which is the atomic number, would be 7. So it is 7 neutrons. This is how you do those tables. I believe you would have been able to do it for ones without the charge, but if there was a charge, and I think you were stuck. All right. let's do one more, I think one more concept from a different vantage point that was also causing some of you some issues. All right, so if I ask you what is the, I believe this is that actual question that I'm not going to work out the actual problem, but I'll give you something similar. What is the identity of the ion, right? I believe that's what was the problem. Okay, we haven't talked about ions in week 1. Okay, that's fair enough. All right, so what's the identity of the ion? So let's say I give you a configuration of, let me go to the periodic table. Okay, so I'll give you, say, 1s2, 2s2, 2p6, and that's it. Okay, and I'll tell you it is a +2 ion. Okay, I think people are having difficulty with this. Of course, I'm not doing the exact homework problem, a slightly different one, but backtrack it. Okay, backtrack it. It's very, very easy. All right, +2, there's 2 ways you could have approached it. One method is not so foolproof, the second method is foolproof. So I'm going to show you the foolproof method. Okay, means you're never going to get this wrong. All right, because we haven't quite learned it, so we have to do it this way. All right, so add what electrons you already have. So we have 10 electrons, right? All right, so that means currently that's not your, remember when I did calculate the number of neutrons, I used the original atomic number, not based on whatever because your protons doesn't change. So you still have to go back to the parent atomic number, and that seems to be the problem here. Currently I've said it's +2 ion, right? So that means this cannot have been the atomic number. Well, that's the clue. When the element has made a +2 ion, we have 10 electrons, but it has lost 2. So add those 2 back. Okay, that means you should have had originally 12 electrons, right? Originally 12 electrons. So what is an element that has 12 electrons? Let's go back to the periodic table. Bingo, it's magnesium, right? Because its atomic number is 12. Means it's got 12 protons and 12 electrons. Does that make sense? I mean, that is all was missing, and I think that was what's causing the problem. Now there's one more I do want to say. I think that was on the quiz. I do want to address that now so that I don't need to create another video for this video. Okay, this is going to be a long video, but I'm going to just record those anyways. All right, so if the question asks you something I didn't teach you, so I was actually going to waive a couple of those questions, but you know what, if you've made an attempt, it's good to learn it. So you see that electronic configurations are also written using Nobel gas configurations. Okay, let's say I write the electronic configuration of, say, sodium. Okay, what's the atomic number of sodium? It is 11, right? So it is 1s2, 2s2, 2p6, and 3s1, I believe. And that's correct, right? That's 11 electrons. Now to write to, the reason this was primarily created was because of the fact that people don't want to write long electronic configurations, and